Hi everyone, really good to see you today. Matthew Kennedy here doing my discussion board 2, module 5 about the history and classroom insights. And this is more of a video that stems from discussion board 1, and we're talking about essentially how does the history of the development of algebra provide clues to why students may struggle in algebra. And I really think the biggest part about algebra and this is just from experience for me, it's also experience from being in a Methods 1 placement. Currently, I am placed in a Methods 1, Algebra 1, and Algebra 2 based classroom. And the biggest struggle I see students have is, all right, I have an equation. We got to manipulate this equation for x. How on earth do I go about this? What is my first step? Am I going to use the quadratic formula? Am I going to just factor and I'm done? Factor by GCF? And it's that thinking process of it's not just going to be plug and jug, we're done. No, we got to think a little bit qualitative here. Maybe think outside the box. How am I going to solve for x here? Now, yeah, for people that are in college, students, maybe you're in the honors path in high school, it's not going to be a problem for some of us. But when we speak about Algebra 1 students, and they're learning about solving these, even multi-step equations, maybe trying to derive why does this point slope formula even work, right? Those are the kind of questions and problems some of these, earlier stage algebra students may have in our classrooms. And not even that, but, I have more than one answer. What can I do with that? Which one's right, which one's wrong? And a good way to put it is, well, what's the context of the problem? Contextualization. We really think about, the videos, the second video, we talked about really nothing but application of algebra, cars, planes, lift, velocity. And I'm not going to go on a tangent on that. That was a little bit about, module 1 talk, discussion board 1 talk, module 5. But it's like, you think about the application of algebra, that's where some of these students may have trouble. It's not only the qualitative work. Oh shoot, this ain't just quantitative work. I got a calculator here and I'm just plugging and jugging, what it says on the screen, right? No, we got an equation. Your first step is, again, I already said it, but how am I going to go, what's the process in solving that solution? And even when I get that solution, what does that mean? Okay, I got an answer of 15. Well, 15 is the slope, so let's not say 15, let's say it in context to the problem. And I know that not every classroom is so high on that, but you better believe my classroom, we're going to be really high on that stuff. We're going to literally say, look, we get an answer. I don't want just 15. Let's circle it. Let's have our units. All about SMP 6 being precise in our language. And I really think algebra stems from being precise in our language. And, it's not that geometry or stats or calculus isn't. But when we speak about algebra, there's just so many ways to go about the problem. And the process you do, what you do with your solutions, that's really what the difficulty is in algebra. And especially when we get into multivariable algebra, even what do they call it? Solving for two equations, like multi-equation. substitution, elimination, and things like that. So, in speaking of, it's connecting this to the readings as well is the last thing I'll do. Hodgkin's was the book that I really focused on a lot, and I took away the most from it. We talked about in that book, or we read about, okay, look, Al Quizme in his development in the book of connections of algebra and stuff when he wrote that book, he started getting some of these vocabulary words, roots, numbers, squares, and we learned about as time goes on, these became more formally developed, and obviously the quadratic equation came to be. They knew more about negative answers. They knew more about infinitely many solutions, no solutions. Essentially, it all started with Al Quizme, but we go forward into realizing, okay, we started from scratch, and as time went on, we get more advanced in the thinking, more sophisticated, if you will. And that's how some of these algebra students will be in connecting this to the difficulties students may have. At first, it might just be, okay, look, I'm going to do the GCF because that's what my teacher said. Or I'm going to use the quadratic formula because that's what they said. But as time goes on, we have to hope our students will have that ability, have those intuitions, go about those reasoning skills to realize, oh shoot, there is no GCF. Or, there's no roots. Well, what do the roots mean? The roots mean when I plug in that value for x, I get a 0 from the function. It's vocabulary. It's mastery. And if our students can get to that point, I would say they came a far way from August algebra to May algebra, and it's a process. I really think the development of algebra, of where we came to be in the thinking process and how we go about the solutions, it directly relates. There's a high association, and thinking about how that relates, it's not really association, it's more, there's a correlation between how the algebraic, thinking processes came to be and how our students think in their development of algebra knowledge. Have a great day. Thank you.